starter question is here. So you've got 1, 2, 3, 4. The first statement is you've been asked to say if this is a true or false statement. Whenever you've got 3/4 times a quarter, is that equal to 16/16?
No.
No.
Okay, so usually the easiest way to find that out is to say to yourself, okay, what is a half of a half? If you get a pizza, you take a half of a half. How much do you get from that pizza?
Quarter.
A quarter. Yeah. So basically, if you remember that, to get a quarter, you need to get 1 times 1 here, and the 2 times 2 at the bottom. So that means whenever you've got to multiply two fractions, you need to time the numerators. 3 times 1, so that should have been 3 here. And then 4 times 4, that should have been 16.
Oh, 16.
Yeah, 4 times 4, which give you 16. So instead of 16/16, it should have been 3/16. And that's why this is not true.
Yep.
So you would say false. And once again, if you just remember what is a half of a half times a half, it's just a quarter, and you can quickly figure that out that way. Okay?
Yeah.
So the next one, this asks you to use your calculator, because you're not expected to do 45 times 2.56. And if you use your calculator, you'll find at the bottom of your calculator there's an x, 10 to the power x. So you type 45 times 2.56, and then you hit that x, 10 to the power x, and you put the -4. So if you try that, this is what should come up on your screen when you type it with the Casio. Can you see it?
How do you do, see when you do the times 10, should the -4 be big after it?
So you see the minus sign that is in between the brackets? You use that minus sign and just 4. There is another way of doing this, but you would need to do the x with a wee square instead of that 10, but that's the easiest way to do it. That's the old way of using your multiply 10 to the power of x. And if you type equal, you should get a fraction. And to give your number into decimal, you need to hit the button called scientific to decimal, yeah, S to D. And that answer should have been 0.01152. So you should get here 0.01152. So try that. Let me know if you get that, because that's the first step.
I got that. And then the full spot.
So how do you get it from the fraction again? SD.
Yeah, there's a button called S.
Yeah, I've got it.
D.
Yeah, I got the exact same.
So that's basically means scientific to decimal. So if you press SD again, it brings you back to the fraction. So basically it gives you the option of going from a decimal to it says scientific, but it's not real the scientific, it's a fraction to a decimal. So now the scientific notation for this, we said to get a scientific notation, the number should be between 1 and 9. So I need to rewrite this with a 1 and 9, but in order to get a 1, you see this decimal point, I need to move it 2 space. See, it's there. Okay. So I'm expecting you to write this as a 1.152 times 10 to the power, I've got to do a number. So I know I've moved 2 position my decimal point, so it's a 2. But because we're talking about a small number and I had to move the decimal point on the right side, you need to put a -2 here. Okay? Now you can quickly check that if you do 1.152 on your calculator, multiply 10 to the power x minus 2, that should be the same answer that we had when we started, when you do your S to D. Yeah? So if you try it with your calculator, that would at least show you that you've got it right or wrong. Yeah?
Yep.
So that's how we go from scientific, if you're asked to write a number in its scientific notation. The next one, we've done quite a few of those. So I'm looking for 2 numbers. If I time them together, I get 8. And if I add them, I get a 6.
4 and 2.
Yeah. So one's going to be 4. The other one is going to be 2. Because I've got a positive 8, you can time 2 negative numbers. That will give you a positive. So both are negative. -4, -2. And you just put your k here. And that's your answer there. K minus 4 times k minus 2.
That's a lot easier than the ones with that we looked at just before we started. I was just,
Yeah, no. It's
it's
a bit tricky because you need to remember that -4, -2 is -6, yeah. And the positive, yeah. And the last question on the starter was 65% of £40. So there's more than one way of doing it, but the easiest way is to find 50% first, then find 10%, and then find 5%. So what is 50%?
20.
20.
Yeah, so that's a half. So you just write £20. What is 10%? You divide by 10. That's what 10% means. That's a 4. And 5% is just half of the 10%, which is a 2. And you've just proven how you can quickly do 65% of 40 by having 20 plus 4 plus 2. And that is your 26. Okay. Okay, so let's have a look today. Any question on that?
No.
No? So the lesson for today is completing the square. So that should be your title for today. So if you got a note jotter, you would just write as a title, completing the square. And I'm going to explain to you what completing the square means and where we can use it. Okay. So we're learning this process. And hopefully by the end of the session, you'll be able to apply the process and solve an equation after we've completed the square. Okay. So basically, we've been looking at quadratics in that form, ax squared plus bx plus c. And completing the square helps us to sketch what we call a parabola, for example. So when we do quadratics, we look at parabolas or read off key information from the parabola. So completing the square formats should look like x plus b square plus c. So how do we get from ax square plus bx plus c to an x plus b square plus c? Just so that you can see b and c here. Those two values are different from the a and the b and the c there. We could have used p and q or s and t or, okay? So basically these just means any numbers, and those b and c are not the same as the a, b, c there. So that's what we're trying to do. So I'm going to show you the technique that we use to be able to do so. Let's say someone asks us, complete the square for x squared plus 2x plus 3. The way to do this is we've been asked to rewrite it as an x plus b squared plus c. You start with x squared plus 2x plus 3. Then you put a small space there and you add the 3. So what do we put in that space? We halve this number and we square it. So if I halve 2, what do I get?
1.
1. And what's 1 square? 1. So we're going to halve the 2, which is 1, and we're going to square it, which is 1. So we write x squared plus 2x plus 1. But because we've added a 1, we need to compensate it. We need to remove it. So if you add 1, to remove 1 is just taking away 1. So we've rewritten this x squared plus 2x plus 3 in this format because looking at this, we can see that x squared plus 2x plus 1, if I was to do two numbers that time together give me 1 and add give me 2, it's 1 and 1. So that should be x plus 1 square minus 1 plus 3 is plus 2. So you can see that we started with x squared plus 2x plus 3, and it's been rewritten as an x plus 1 square plus 2. And to do so, we've halved the 2, we've squared it by adding that number, and we had to compensate by taking away what we added because the only way to keep the balance between this original function to this is to take that away. And that's what they mean by completing the square. So I'm gonna practice a couple more so that you get an idea. So this is the first time you've probably seen it, how it's done. Okay, but these are the steps. Half the coefficient of x, which is 2, square it, and then compensate it. So whatever you've added, you take away. So b equal 1 and c equal 2. That's our answer for this first exercise. This time I've got x squared minus 4x plus 6. Remember what we said? We're looking to rewrite x squared minus 4x plus 6 with an x squared minus 4x. So we're going to halve the negative 4. What's half of negative 4?
2.
So what's half of 4?
2.
2.
What's half of negative 4?
Negative 2.
Yeah. So there's a difference. So whenever you could see straight away the difference because I've emphasized on the negative, but if someone gives you a negative number, if you half it, it's still negative 2 because negative 2 plus negative 2 will give you negative 4.
Mm-hmm.
Okay, so that's the difference. So half the x term and square it. Because you square negative 2, it becomes plus 4. But then we need to compensate because we've added 4, we need to take away 4. Okay? So that's how we do it. And now x squared minus 4x plus 4, two numbers that you time together gives you 4, and you add them gives you negative 4. It's negative 2, because negative 2 plus negative 2 give me 4. Remember, this is a negative 4 here. So it's going to be x minus 2 square. Then 6 minus 4 is just 2. So we've rewritten now x squared minus 4x plus 6 as a x minus 2 square plus 2, and my b and c are just, oops, sorry. My b and c here, b equal 2, or b equal negative 2, and c.
Would this be a question, Adrian, that they would ask just to identify what, to complete a square, and you'd have to identify what b and c were?
Yeah.
In that format. Okay,
in
so
that
that's
format. So they would give you the question there, complete the square for x squared minus 4x plus 6. Then they expect you to know that you need to halve this number here and square it and then compensate it.
Okay.
And then you would factorize this, because this,
yeah,
because when you factorize this, it's the number here, you notice it's always the number that we've halved.
Mm-hmm.
Remember in the previous example, we had x plus 1 square. Here we get x minus 2 square. So you don't even need to factorize. You just put that number that you had half. But because we've been working with factorization, you can quickly check the two numbers that you time together give me plus 4 is negative 2. And if you add them, is give me negative 4. Okay. So let's have a look at a couple of more examples. I've got this time x squared plus 14x minus 3 and x squared minus 8x plus 2. I've been asked to complete the square. So remember what we said, we take the coefficients of x, we half it. So it's 14 divided by 2. 7. And we square it.
49.
49. Okay.
Plus 49.
And then minus 3. But because we've added plus 49, we need to take away 49. Yeah?
Yeah.
So then you end up with x squared plus 14x plus 49 minus 3 minus 49. And just like I said, half of 14 is 7. X plus 7 squared minus 52 is us having completed the square for this. X squared plus 14x minus 3. So the next one, I will let you try it on your own.
Don't give them the answers. Don't give them the answers. Let them struggle.
Okay. So negative 8. What's half of negative 8?
4 squared 16.
Yeah, so negative 4. Remember, it's negative 4.
Oh.
And then because I add plus 16, I need to compensate.
Negative, take away 16.
Take away 16. And
to x minus 4.
And to complete the square, you just half that negative 8 that we had. You just write it as x minus 4 square minus 14, because 2 minus 16 is just minus 14. Okay. So to be honest, b should be the easiest one to get. B is just half of this coefficient here. It's c that you need to play with because you need to compensate. But to me, b should come straight away. You see that 14, half 14 is 7. -8, half -8 is -4. Okay? Just the same way like we had in the previous example, but the compensation is important. So, in this exercise, have a look. The question is, we've got x squared plus 2x minus 8. Again, we're looking at completing a square because they've asked us to express in the form. Have you noticed this time instead of the b and the c, they've changed it as an a and a minus b, so they can do it the way they want. But the only thing we need to do here is to complete the square for x squared plus 2x minus 8. So have a go at this. I'm gonna pause again and see if you can complete the square for this one. I forgot to resume recording, but there you go. So it's x plus 1 square minus 9 when we compensate with a minus 1. Then a equal 1 and b equal 9.
I was just curious in just terms of how you would just lay that out, you know, like, because it obviously says minus b is that's the way it's laid out. And
yeah.
Obviously the b is just essentially 9, regardless of the minus.
Yeah. So let's try this one. Have you noticed in this exercise, the minus we had, they've changed it into a plus. Now let's see if we can get this in this format. Okay, so I'm going to give you a couple of minutes to try this one. Coding. Okay, so in this case here, I'm looking at x squared plus 6x. I'm going to half the 6 and square it. So what's half of 6?
3.
Square 3 is 9.
9.
Okay, so that's my first part. Plus 11, but because I've added a 9, I need to take it away. Yeah?
Yep.
And what we said was x squared plus 6x plus 9 is just x plus 3 square. You can check it if you want. 3 times 3 is 9. 3x plus 3x is 6x. Plus 11 minus 9 is just plus 2. Now, I'm looking at a equals 3. I'm looking at b, and b is just 2. And that's how you would answer this question. 2 marks. Oops. Okay.
See how it says write it in the form? You don't actually just having a equals 3 and b equals 2 to the side is enough. You don't need to write out that form as bracket x plus 3 close bracket squared or
plus 2, yeah. So you don't need to write a equals 3, b equals 2. Because what you've done, you've answered the question, you've written it in this form. Another question could be, you know, give me the value of a and b in this form, x plus a square plus b, by completing the square of f of x equal x squared plus 6x plus 11. Then you give the value a equals 3, b equal 2 at the end. But you write, because they've just asked us, write it in this form, you just write it in this form. So x squared plus 6x plus 9 or plus 11 is just x plus 3 squared plus 2. Okay.
Right. Okay,
so you would get the mark by writing it like that, but you would get the mark as well if you had put a equal 3, b equal 2.
Okay.
Okay. So yeah, you wouldn't get penalized. The only problem is if you had written a equal 3 and b equal -2, and because you wrote a wrong answer, you wouldn't get the 2 marks. So you need to watch. If you do more
what
than,
do you mean if you wrote -2?
let's say I had
2 where?
Let's say I had put x plus 3 squared plus 2, and for some reason I went and put b equal -2. Then I've contradicted myself there. So it's as if I've given 2 answers.
Yeah.
And because we give two different answers, unfortunately in math, the teacher won't pick one or the other. It will just not give you, it will say, okay, you're not too sure what you're doing here.
So you have loads of
Yeah.
coffee when that comes across the next time. You'll get it.
Okay.
Oh, no.
Loads of coffee.
Okay, so I've got a few questions just to practice this. Okay. So the exercise 2 and 3 is very much like what we've done so far, completing the square. Okay. The number 4 is a bit harder. So maybe what we'll do is, these are, yeah, you're going to do these as homework so that we don't spend too much time. But I'm going to show you how we do number 4 because it includes some fractions. Okay. So I'm going to step by step show you how we would need to do this. So to do number 4, so yeah, 2 and 3, I'm just going to put here HW so that you know it's your homework. It's very much the same as what we've done in the previous 6 examples.
What number is that slide?
So slide number 9.
You'll send these in. We want Adrian, of course.
Yeah, I will send it.
Yeah,
so slide number 9. And we'll do this one together because what I find most of the time is if you've never done one with fractions, some people might find it a bit too difficult. But let's work our way through it. The first thing we said we were going to do, we were going to put x squared plus 3x. I'm going to have to add a number and then compensate it. Yeah. So the number we add is half this number in the middle here. Yeah. So this would mean I've got equal x squared. So it's 1.5, but we add the square of it. X squared plus 3x. I'm going to add 3/2 square. What's 3 divided by 2 square? So that you know, basically I have 3 divided by 2 times 3 divided by 2. What did we say about fraction when we time them? We time the numerators, yeah, and the time the denominators. So we've added 9/4. So that was the only difficulty here, but now we need to compensate. Because we've added 9/4, we need to take away 9/4. Okay, minus 9/4. So to complete the square for this, we would just write it's x plus 3/2, which is half of 3. 3/2 square. So we've completed the first part. So that was our a value, if you remember. But now I need to do 4 minus 9/4. So I'm going to use the side of the paper here so that you see how we do 4 minus 9/4.
You try and make that 4 or 4/1 or 1, you know, trying to, yeah.
First thing first, you make it as a fraction. A 4 is a 4/1. And now the only way I can add or subtract fractions, it's if they've got the same denominator. I need to change that 1 into a 4. What do I need to do to 1 to get a 4? I need to time 1 by 4. But whatever you do at the bottom of your fraction, you need to do the same at the top of your fraction to get what we call an equivalent fraction in order to keep the same ratio. So what's 4 times 4?
16.
16. And what's 4 times 1?
4.
4.
4. So you get 16 over 4 minus 9 over 4. Okay. And now we're able to just say my answer is going to be a number over 4. So when you add or subtract fractions, the answer is the common denominator that you find as your denominator. And at the top, you just do 16 minus 9. What's 16 minus 9?
5.
7.
Sorry.
So
That's
it's the same as 17 minus 10, because I've added 1 on that side. I need to add to keep that same ratio. 16 minus 9 is the same as 17 minus 10. So if you think that way, it's much easier. Because I can see why someone might think, oh, that might be 5 because there's a 1 difference between the 10. Just add a 1, 17, add a 1, 10. 17 minus 10 is 7. Okay?
Yeah.
So that's my 4 minus 9 over 4 is just positive 7 over 4. And that's your B here. So if you were asked to write this as a x plus a square plus b, a is 3 over 2 and b is 7 over 4. Okay?
Yeah.
So you could see why these kind of questions would have a bit more marks in it, because it's asking whoever's working on this to be able to square fractions, to be able to, sub fractions. And sometimes you get them. I've not seen them, to be honest, quite a lot, because usually completing a square like question like this is just a 2 marks. So they don't get, you will get other question where you will have fractions on its own, but it's always good to be able to manipulate fractions. Okay.
See from like what we're learning, see during an exam or like a I know you said there's like a kind of test thing at the end of October. Will there be one question from each thing, or is it just do you tend to just get a mix of them? Do you know what I mean? Is there like things that tend to come up in every exam, like certs come up in every exam, or
yeah,
is it a kind of generalized mix of it's just a kind of luck of the draw?
So it's a bit, so sometime you will see, like, remember when we had touch on some of the difference of 2 squares?
Mm-hmm.
You can get a Pythagoras there, but then we've asked you to give the answer in a surd form. So you can see that straight away you're doing the difference of 2 square plus you put a surd in it. So the questions are a bit like that. It's not going to be just a question on surd, just a question on completing a square, for example. So usually they are, so the question usually will touch, but they are separate enough so that even if you don't get the start, you will still get some marks, so that you don't get penalized because, oh, I can't do the start of it. So the questions are always written to give the possibility to get marks rather than penalize the student.
Okay.
Okay.
Thanks.
No worries. Okay, so the rest you can do them as homework, I would say. Okay. All right, so I think we're gonna take a break. We're halfway through. You can take a 10 minutes break today. And then we look at this second one. Why would you use, where could you use a completing the square, for example? And that's the next part. You can solve an equation by completing a square, for example. Okay.
Coffee.
Yeah, I think it took us a while to go through, going through the homework, but I think it's important to make sure that we are comfortable with factorizing.
Yeah.
Okay. So see you in 10 minutes.